Okay, so for in last class we started discussing if we add multiple pumps, what will be the final pump characteristics, like what will be the combined efficiency, what will be the combined power, what will be the operating points and everything. So we know there can be two ways to add multiple pumps in a system. It can be in series or in parallel. So remind me, if we add the pumps in series, should we get more pump head or more flow in the system? We should get more pump head, just like that. So this pump will give up to that point, and the next pump will add another head here, so we will get more head. Now if we need more flow, in which way we should connect the pumps, in series or parallel? The parallel, because parallel is like two pumps or three pumps will work parallelly, and you know when people work parallelly, that means we will get more work or something like that. Okay, so class example 10 was we had two pumps, pump A and pump B. For pump A, 8-inch diameter, 1450 rpm rotational speed. For pump B, it was 10-inch diameter, 1750 rpm. And we had this system, two open reservoir system, with some information about major and minor losses. So what we did as our step one, at first we identified what type of connection we have here. So it was in series. Then computation of system head curve. So we added all the equations and everything for the head curve, and we found that one, ED plus 29.36. Now the next step was, I think we stopped here, right? Did we do something about the system curve, plotting or something? Okay, so what we will do, since we have a curve, obviously the next step is we need to plot the system curve and the composite pump head capacity curve, right? Now for the system curve, whenever, for any curve, whenever you have an equation, that simply means if you choose some independent values, it should give you some values for the dependent one. So here Q was the independent factor here, like for different Q, you should get different HP values, right? Now, since we have a curve here, and the beauty of a curve, having a curve is it should give you H pump value for any possible Q values, right? Now, we can get any possible Q values, but that will not help us. So we need to be strategic a little bit. Since we are trying to find the composite curve and system curve and the operating point, so it will be good if we choose the same range of independent value or Q, right? So here, either you can pick some Q values, random Q values. You just need to make sure that it should be within this range, 0 to 1200, or you can directly pick these four values and get the Q values for the system head curve. Okay, there is nothing wrong with picking some random values as long as that is within the range of like 0 to 1500, 2000, because that is the range of pump head curve. Okay, so without even asking you, I already added the same Q values, but if you want to work with some random values, that should be the, I didn't realize I already added that, but if you want to pick some random values like 0, 500, 1000, 1500, you can do that one as well. So do whatever you want to do on your copy, okay? So in my copy, since I already added these values, so I will just work with this one. If you want to work with this one, that's fine. If you want to pick some random values, that is fine as well, okay? So do whatever you want to do. If you decide to work with these values, I will ask you for the final answer for these values, okay? Okay, so what was the equation we got? 80 plus 29.36, okay? So let's write it down. 80 plus 29.36 Q square. Now, this equation was developed based on Q is in CFS, but we have the Q is in GPM. That's why we need to convert the Q into CFS also, just for calculation purpose. So do that and give me the value for HP. And 449 is the conversion factor. The actual conversion factor is 448.8, but you can round that to 449. Okay. So the first one will be obviously 0 and 18. Give me the other values for 400, 800, 1200. So for 400, what is the Q in CFS? 0.89. For 800, 1.78. Okay. For 1200 GPM, 2.67. Okay. Now for HP, obviously the first one is 80 because Q is 0. What about the second one? 98.5. I got a little bit higher than that. That's what I got, 103. Is it rounding issues or? Okay. Okay, 103 point. I got 25. What about number 3? What? 0, 2. What about 1200? Okay. 289.285. Okay. One thing, make sure you have your lesson 15 open, the very last page, because that page has all the steps. So make sure that page is open because we will follow all the steps listed there. Okay. Lesson 15, the very last page. So you should have something like that. Some steps. Where is that? Here? Steps for multiple pumps, something like that. Lesson 15, last page, where you have all the steps and equation. Okay. Now, once you have the system curve data points, what should be the next step you should do? What is the purpose of finding these values?
So you can graph it.
Yes. So that should be the next step. Plot which column and which column. Obviously, you need to plot the pump head, but for Q, which column you should use? The GPM or CFS?
GPM.
The GPM. CFS one is for calculation purpose, but the GPM is only because of we have the plot I already gave you that is in GPM. So that's why you should plot everything in GPM. So plot these two for system curve, okay? And if you plot that, the system curve should look like this, the purple one. Plot the Q is in GPM and HP is in feet. Everyone, please plot that. And if you plot that properly, the graph should look like the purple line. So does it look like that, the purple line? Okay. Those who are done, Can you tell me what will be the next step? We have one curve, but we need one more curve. We are working with multiple pumps here, right? And if you look at the curve, we have individual curve, but we don't have the combined one. So the next step should be to develop the combined head capacity curve, okay? So everyone, are you done with system curve plotting? Okay, then I can move forward. Okay, so the next one, development of pump characteristics curve. And these pumps are connected in series. So remind me again, should we add heads together or the capacity together? We should add the heads together. So series connection. Individual pump head should be added together to get the combined head or capacity curve. Okay, now from where I will get the individual pump head curve value? Do we know? The table 1, yes. So you will copy all the pump characteristic data from table 1. So that should be the Q in GPM. That should be HA in feet, HB in feet, and the composite curve will be HA plus HB. Now for this curve, it should be composite head. Okay. So the Q values are 0, 400, 800, 1200. The head is 186, 182, 168, 144, 172, 166, 140, 90. Okay, find the combined head. Add these two and find the combined one. So what is the first number? 186 plus 172 is
358,
358. The next one is
348,
348. The next one
308,
and the last one.
234.
Okay, thank you. So now you have all the values for combined head capacity curve. What should be the next step? Plot. Yes. So which one you will plot? Which column? So this one and this one. Plot these two. The Q is in GPM, H is in feet. Plot these two. And now you have composite head part and the system part. So you should get the operating point for of the system converter. All the values on here, you already have that. So just plot C1 will be the system part and table 2 will be the you don't need to do that estimate because you already have the cost. Okay, so I saw all of you are plotting, which is great. So if you do that, did you get something like that? The combined head capacity curve, the top one? No. You are not getting that because you are not done or you got wrong values for composite head. Yeah, which one is that? Now he's so busy to fix that problem. Okay, that's good. Okay, so what is the operating point you got? And which one is the operating point actually?
Where it's Q0. Oh, wait, no.
That is a shut off head. This is the operating point, right? Okay, so that means just draw vertical line, one vertical line, one horizontal line at this point. Okay. So what is the operating Q?
1100.
This is the operating Q, right? Something close to 1100 or 1090, something like that. So obviously it will depend on how you plot it, and as long as it's close to 1100, you should be fine. All of you got that? So I will just write down 1100 GPM overall. Okay. What about H? It's pretty close to 260, so maybe 255 will be a good estimation. 255 feet. All of you got that? Great. So that was the solution for A, class example 10A, operating point and discharge. What should we need to determine for this class example? What is the next thing we need to do? Efficiency of the combined pump and the input power for the combined pump, right? That means when these pumps are connected in series, what will be the combined efficiency and what will be the combined power? That's what we need to determine. So everything of that efficiency and power, you can imagine it will be based on these operating points values, right? Because that's where these are operating. Now, what should we do? Now, how this 1100 GPM is made? Obviously, pump A contributed something, pump B contributed something, right? So that's what we need to find right now, like which, oh, I'm sorry, this Q is same, head is different, head is being added in the pumps in series, right? So in this 255, pump A is contributing something, pump B is contributing something. So we need to find those individual heads. What is the best way to find the individual head? Like how much pump A is contributing, how much pump B is contributing to this 255? What is the best way to find that? Is there any way?
Where they pass the line?
Like this one?
Yes, ma'am.
And this one? Yes, that's the way, because Q is same, you can see that, but we need to find how much pump A is contributing, how much pump B is contributing. And you can get that value from these two green circle. Okay. Now, can you find these two values, these two green circle? What is the pump head A and what is the pump head B at operating discharge? How can you find that? What is the way? You just need to draw some horizontal line at this point and this point. And summation of those two should be 255 or close to 255. Okay, because that's what the combined head is. Okay, so what value you got for pump A? Something around 150 maybe, or what? Here,
Yes, ma'am.
right? 150 something. Okay, 152. Great. What about pump head B here? 105 or something like that. So in together we are getting 257, but 108. Okay. So I will write down that, but you see, if you add this together, you are getting 260. So that means we are not getting all the values 100% correct. But you can always check your calculation that if you add these two and get 270, there must be something wrong. But if you're getting 250 and instead of 255, if you get 260, we know that's because of plotting we did, right? Okay, so I will keep 152 and 108. You keep whatever you got. Okay, now if I go to the next slide, you will see there is a space, or in your copy, you will see the space for combined efficiency and combined curve. So if I just go there, I will just write down combined efficiency, power combined. What should be the equation for combined efficiency and combined power? It is kind of like weighted average of efficiency and weighted average of power in terms of individual head. So the equation is HA plus HB from where I got this equation. In your lesson 15, you have this set of equation here. Okay. So from there, I'm using this epsilon eta and the power one. Okay. So let's do that. And for the power, gamma H or gamma Q, I will make a note on this side that power output equals to gamma QH. That's what we know, right? And power input equals to power output over yes. So that's what we are looking for here. Power combined is actually power input combined here. So what you will do, since we have 2H now, right, for pump, so what you can do, HA plus HB, or the combined head, that is okay, and the epsilon. Now, in your question, did they mention that you need to combine efficient input power in? Okay, they didn't say anything that you need to calculate in horsepower, but if you want to convert everything in horsepower, you can divide by 550, right? Now you see, you need HA and HB, which we already have. what about efficiency A and efficiency B? We need to find that one also, right? So let's do that. What is the way to find the efficiency A and efficiency B? You will find this number and draw the horizontal line, right? So it will be kind of like that. So what is the efficiency A? I'll just write down this one. Kind of 71 maybe, right? Something like that. So 71%. What about B? Kind of 75 or 76 maybe. Okay, good. Now we have everything. Can you calculate combined efficiency and combined power from the given equation? You may get a little bit different from 71 and 76, and that's completely okay. So before I proceed further, raise your hand if you understood what we did here and why we are finding all the eta and h values. What about the other? You didn't understand? Should I explain again? Okay, so here our main purpose is to get the combined operating power, efficiency, and the combined operating points, right? Like once we add the pumps in series. Now, how we will do that? We know that combined curve will be based on how we are connecting the pumps, whether in series or parallel. So in series, we know the head will be increased. That's why here we added the individual head to get the composite head, okay? And then we plot that, these two, right? And that is the operating point after adding two pumps in series, Q and H. Now, when we need to find combined efficiency and combined power, obviously, each pump will have their share on the combined power and the efficiency. Now, how we will know that? That's why these are the equation. Like this will tell you how they are connected or what will be the relation for individual pumps in combination in series, right? So you see we need head A, head B, eta A, eta B, and everything should be at operating points like operating discharge and head, okay? So how to find everything on operating discharge? Obviously, you can draw a straight line and from the point where it hit the individual line, you can get eta A, eta B, HA, HB. So that's what we did here, okay? Now you got a little bit better idea about this one? Okay, great. So now we have eta A, eta B, HA, HB. The reason I'm asking this because for class example 11, we need to do kind of same thing. So it's better to spend time on this one and do some practice on 11, class example 11, okay? Okay, good. So combined head curve, we have, what was the number we got? 152, 108, and oops. 152, 108, 152 over 71, 108 over 76. So what is that number in percentage?
72.
72? Okay, great.
Actually, 73.
That's okay. Whatever number you got, if it's within the close range of 72, 73, that should be fine. Okay. Now gamma, we need to use that in SI system or FPS system. It's FPS system, so it will be 62.4. Q should be the operating discharge, which is 1100, right? HA should be 152 plus 108. Eta is 73%. You just got that. So I will use 0.73, 550. Now, 1100 is in GPM. Should we work with GPM or can we work with GPM here? No, because we need to convert that into standard unit and the conversion factor is 449 or 448.8. So find this value and the final unit should be horsepower, right? Okay, so find this one. I will just add one more thing, that is the power input combined. Okay, so what number you got?
I got 0.99.
0.99. Because you are using the efficiency in percentage, I guess. That's why. 99. Okay. I got 97.9 from my other calculation, but obviously I'm using a little bit different values. So it should be 99, 97, 98, 100, something like that. Okay. So all of you got that. You got the main thing that since we need to find the operating point, that means we need pump characteristics curve, we need system curve, and then the other things, right? Okay, great. We still have 15 minutes, which is a good amount of time to do another class example. So all of you have class example 11, right? Okay, this time, the only difference will be class example 11, the pumps are connected in which way? Series or parallel? This time they are connected in parallel. So this one is A, this one is B. Both of them are taking water from point 1 and they are delivering the water to point 2. Make this correction in your copy. Point 2 should be open reservoir. I just add a water surface. Okay. Now here you see again you have pump A, 8-inch diameter, 1450 RPM. You have pump B, 10-inch, 1750 RPM. You also have a plot with this data, right? With efficiency and power, something like that. Okay, good. Now, these pumps, they are arranged in parallel in a system having a total static head 40, okay? So that is the difference between A and B, 40 feet. The pipeline comprises 9-inch diameter pipe of 1200 feet length with a minor loss is 20 times the velocity head. So minor loss will be 20, V square over 2G. Considering F, 0.22 is DW equation, that's the Weisbach equation, and 2 open reservoir system. Again, determine the operating head and discharge, Q and H, efficiency of the combined pump, and the input brake horsepower for the combined pump. The same thing, but this time they are connected in parallel and we will see how much that affect the efficiency and the power, okay? Now in your copy, you already have the system curve calculation because it's the same thing. So I thought maybe I would spend more time on finding the results. So since it's 2 open reservoir system, you know the HP will be delta Z plus head loss, right? We already know that. And for head loss, you have major, minor head loss. major, minor, and what will be the KL value here? 20 times the velocity here. So K value is 20, right? Okay. And once you do all the calculation, you should get the very final equation 40 plus 4.39 Q square. So in your copy, you have all the detailed calculation. Okay. So let's start working on this part. Step 1, pipes are connected in what? Okay, that is a very important step to identify what are the connection types. Okay, computation for system head curve. Once you have the curve, you can assume all the values and plot that, right? So that's what we did, but there is a note here. Can anyone read the note you have here? Who will read that? Do that very quickly.
As the pumps are connected in parallel, Q max value 2500 was chosen in such a way that it would be greater than the summation of individual Q in each pump.
Thank you. So when the pumps are connected in parallel, should we add the flow or should we add the head? Flow. And what is the maximum flow for pump A? 1440. What is the maximum flow for pump B? 980 or something like that, right? Now, since we will add the pumps and we need to get a point where these two curves will cross each other, just for that purpose, for system head computation, I chose the maximum value which is greater than the summation of individual one, so that still I can get a like meeting point. Okay, so that's why I chose this one. It can be 3000, it can be 3500, it doesn't matter as long as it's greater than the summation of these two. Okay, so you already have the system curve, this one. Do you have that in your copy? So we will start working from this step. Okay, now you told me since they are connected in parallel, we should add individual flow or head. Okay, flow to get the combined head capacity curve and from where I will get all the Q and H values for this part. Do we have any value anywhere? From table 1. Okay, so copy everything here. GPM, feet. So we have 9 minutes. Within these 9 minutes, I want you to find the composite curve, plot that, and find the operating points. Okay, and if you do all the calculation properly, you should get operating point Q something around 2000 and H something around 140 feet. So your task is add these, plot these, find the operating point. Okay? You want to work with your friends, that is okay. You want to work individually, that is okay. But find the operating point. At first, get all the values from table 1. Yes, yes.
That mad at me last night, and
threw me off my head, and I like showed up into a ball and fell on the concrete, and right there, I fell
Here.
right where the bird.
Since you're calling like QA and QB, and you need to take everything. This one is everything about the pump, right? This one is for the QB.
Right where the
Yeah.
band
Yeah, that one is cool. That's true. So you here.
No, he just gets like, instead of like insulting us
You can
back,
get all the values
he
from
just
here.
like
This one is
starts
the QA capacity.
pulling,
This one is the QB.
he started like tucking me in really aggressively, and I told him it's not. So it
That's
was-
the capacity. You can-
I was making fun of him for something, but I don't remember what
This is
for.
that. So you can copy all the values to that. Okay? Hurry up, class.
Tristan watched it at full volume and
This
it
one is here. On the back. Okay? And the cable will
Why? Anthony busted out laughing, and there was like, I want to see it.
and all the
So it
values
was all
will
their
be
high
like
school
QB.
friends.
So make the copies here, I guess.
So now we plot these.
Plot the pump combined curve. Yes. This is the one last copy I have. That's okay. These are extras.
So heading 20.
So this one is 186, 172, 160, 140, 120, 0, 720, 960, 1240. Okay, for pump B, you don't have anything for 186. That's because at 172, they got the zero flow. So obviously after that head, any head will give the zero flow. Okay, what is the very first composite flow for 186? Obviously it's zero. What about next one is 720, right? What about the last three? 1460, then? And the very last one, 2420. Now you will plot and give me the operating point. Everyone should have operating point before you leave today. You
21.
have 2 minutes. Find the operating point, like Q and H, and check with me if that is the correct answer or not. Yes. Mhm. Yes, yes, because everything here is in GPM. We look at that. So when you add that, the final one will be in GPM also. No, this one is the 100. That means 100, 200. Yes, yes, yes. Done? Okay, give me one more thing, but draw a line or do something so that I can see the final answer. place for the test.
Man,
Yes.
I got 21, 20, and 130.
How did you get that much accurate? 21, 20.
I just guess.
Yeah. Write down the unit. For Q, it should be what? Okay. Okay, I'm telling you, if you don't show me the result, you are not allowed to leave. So show me the result. Yeah, this is 100. So that should be 200. Write down that. Okay. Still, it's not 200. It should be 2,000. Because you already have these two here and that's yeah.
Oh, yeah.
Okay. What else wants to check them?
Yeah. I bet I got a C though. This is wrong. No. No. I was done in like, there were two questions that I didn't know. And I was done in like 30 minutes.
I have some extra copies here. Take that and start working on that. I'm serious, you are not able to finish it. So I don't see the answer. Yes. There is one, example 11 on top of that chart. Okay. They take the answer. Those who are done, you can leave. Because we have only 1 minute. Did you find that?
No, ma'am, it's all your
Here,
papers
here,
for that.
here. That's example 11. Here. Okay. Okay.
We just have to find operating point.
Yes, for today's class, that was the plan. Okay. I can give you. I need to give you. You are all by yourself because they are allowed to go. I think that's but this one is in 100. Okay.
So is there homework in this class this weekend?
Yes, 2100.
What?
Yeah,
So is there
because
homework in
this
this
is
class?
100, it's not good.
Oh.
Okay. Yeah.
Oh, I think I remember why. It's because I sent him the post of the guy doing this. He didn't know what that was. I was like, oops.
That's true.
He gets
One thing I really liked about the homework was I felt like I couldn't do the F values properly.
Yeah.
The only
Louise, I
thing you know what
You was that straight line, right?
the ratio flow we had mostly was the laminar and in between the transition. That's why it was actually hard. Other if it was the clearly turbulent flow, it was much easier to get that. Yeah.
Yeah.
But
I was a
then,
little confused about.
but that was the main purpose of doing that experiment. Just to struggle a little bit, understand how to work on that.
Which one?
Did that.
Ma'am, have a good weekend.
You too.
Thank you.
Write down that and good morning.
If I was by for a solution. It's not even ours. But my other two.